Okay, hello everyone. A few months ago, I gave a talk at Chippy, the Chicago Python users group, and I was asked to go a little bit slower and go into more depth on what I went over on that talk. So I'm making this video to do that. So we got this canvas here running, and you can see that we have a bunch of slide elements. Each one of these slide elements, we have a bit of markdown that's going to kind of tell us about what we have going on here. We also have a little code block here that has a bit of code that is going to be executed at runtime. We have a few buttons here that will automatically put in some code as if you typed it into REPL. Down here we have a kind of REPL prompt. So we have a bit of a terminal and a spot where we can stick in some code. And you can see here that we can put in some code and use it just like we would with a REPL prompt. So without any further ado, let's get started. And this talk was about Python generators, and we're going to go over how to use generators, how to construct them, what they're good for. In our particular case, they are really good for running robots, and you can run our robots with generators to make them do fun and useful things very easily. You can create something that's very simple on the outside, but expands very large to create some complex behaviors as they get going. So without any further ado, let's get started. And you can see up here that we have a generator function that we have created here. With generators, you are going to yield something back. So this is kind of like return, except instead of return, it never actually closes this generator object. So let's go ahead and we'll start here and we'll just kind of type our first one. You can see here that we have called next on this generator object. And you can see here that we got our first value back. So let's go ahead and just go through these. My name is Andrew Wingate. I run a robotics company called Evezer. And this particular talk here is going to be about generators. So let's go ahead and get started. And right here, we have another generator function here. I've used kind of the same names as we're going across these, so everything can stay pretty simple. But in the most simplest terms, you can think of generators as iterables. So again, you will create some generator. You can see here that we have gen, and when we query on gen, we will get back a generator object, which is this the instantiation of this generator function. So again, generators seem a little bit complex. When you first start using them, they require a little bit of hand-holding. But again, as you really get going with these, you understand that they're pretty powerful and you can do some really fun things with this. So let's go ahead and we will go ahead and get started. So we have created our generator called gen, we've called next, and we've gotten our one. Now, again, one of the really cool things about generators is we still have this generator open, but we can go ahead and do other things in the meantime. We don't necessarily have to exhaust this entire generator before we go on to something else like you would with, say, a for loop. So let's go ahead and continue on. We have gotten our second value of 2. We get 3. So now we have gotten to the end of our generator function here, and we're going to call next on it again. So what we have here is we are going to be raising a stop iteration. Now you can catch these and do fun things or anything like that, but basically our generator is exhausted, and each time that we call next on this, we're just going to keep raising this error of a stop iteration error. Again, you can just create a new generator object, go ahead, and we can just start all over. Also, you don't necessarily need to finish a generator before you start another one. We only got to 2 here. We went and just created a new generator, and you can see here now that we have just started from the beginning. So again, generators can be thought of as iterators in their most simplistic form, and we can just go through and next on these things. So another nice thing about generators is we have the concept of lazy execution. So we can have something that acts like a list, but we don't necessarily have to create that whole list or keep it in memory. So with this particular one here, you can see that we have gen again. And this is just like a list comprehension, but we couldn't actually have this list comprehension because this list comprehension would actually have a trillion items in here. So we can have a generator that doesn't actually have to hold all trillion of these, but we can still do useful operations on these when the time has come. The word for this is called lazy execution. So again, this is just like a list comprehension, but you can see that we have the parentheses, and that is going to give us a generator expression comprehension. So gen here is a generator expression. It's another type of generator. So let's go ahead and just go on this, and you can see that, the first value is 0. And, this one would basically just give us all of the even numbers in a series every time that we ask for another one. So again, you can save tons of memory. You can save time because we don't have to execute some list when we first instantiate this object. It wouldn't be executed fully right then. We can also, if you're using some other variables and whatever it is would change by the time that you actually go ahead and call next on this, you can, have some more like real data that's put into some function or something if you're iterating over this generator at the time that it's called. So moving on, again, generators can be thought of as iterables. So again, we can take a for loop, and we can go ahead and stick our functions into a for loop, and the for loop will automatically do all of this nexting so that we don't have to take care of that. So in this particular example here, we are basically creating our generator function here. So you can see here that we have this while loop. So we're going to stick in here for as long as we have beers on the wall. And basically this is just like the take the beers off the wall song. And you can see here that we will kind of stick in here, and we'll just go yield, yield, yield on this every single time until we end up with 0 beers on the wall. And then normally we would get a stop iteration. But let's go ahead and just press this here, and you can see that when we did sing for 5 beers, we for beer in take down beers, we're just going to post, and post basically just puts it into this little terminal here. And you can see here that we have gone through 5 times, and we have posted each time what we have yield. So let's go ahead again, and we can just kind of do this a little bit more manually. So let's go ahead and let's create a new generator object, and we will instantiate the takedown function. And let's just do 2 to keep it nice and easy. So again, we have this generator object called gen. Let's go ahead and next on this guy. So you can see here we have 2 that we passed in when we instantiated our generator function. We have gotten back that there are 2 bottles of beer on the wall. So we can go ahead and we can do this again. We will next on our generator. You can see that there's 1. Let's go ahead and next one last time here. And you can see that now we have 0 bottles of beer on the wall, and this has raised a stop iteration. So you can see that when we did the for loop, this stop iteration was handled silently under the hood. And when you're doing this manually, you'll have to be aware that a stop iteration will have to be handled at some point, depending on what it is that you're doing. So now we have yield from. And when I first started using generators, yield from, I kind of didn't really get a good handle on what it was right away. It seems the syntax seems a little bit confusing at first, but once you really get a feel for it, you can understand that basically yield from is just an implicit way of saying I want to create a for loop on this generator and go ahead and run through that entire generator until it's exhausted. So you can see here that we have created a bunch of different iterables. This first one, is a generator itself. This one is just a list. We have a dictionary, and then we just have a string. So again, you can iterate through any of these. It's basically just like if you did a for loop on any of these, is what you're going to get back when you do yield from. So again, we have a bunch of different generators. We are going to create this generator function. And in this one, for generator, for gen in gens. So we got gens here. We're going to go through, and then in each one of these, we are going to exhaust that particular generator or iterable until it is done. So let's go ahead and just get started. So comprehension A, you can see here that we're just doing a string, and we're going to pass in the letter that it is out of this particular string. So you can see here, B, C. Now we have exhausted this entire generator expression here. So basically we have exhausted again this yield from. So when we hit next again, we are going to not only handle this stop iteration silently, but we are going to now go on to this next iterable, which in this case is a list. Again, so we got the string 1. Let's do it again. 2 and 3. And again, this yield from now is exhausted. We're going to go next to our next generator. Here we have a dictionary. You're going to see that these are going to be out of order. Up here, you can see that we're running in MicroPython. So this is something to be aware of, that if you're using MicroPython, that your keys will essentially be random. There's a reason for why it's going to be like this, but just something to be aware of, that it won't preserve order. MicroPython won't preserve order like Python would. So it's something to keep in mind, and as long as you know, this isn't a big deal. So again, second, first, next we're going to get third. Again, we have handled the stop iteration silently, A, B, C, and now, finally, we're going to get our stop iteration. So again, we created this generator function that's going to take in a bunch of iterables, a list of iterables. So we have iterables of iterables, and we're kind of just like going through these. And so keep in mind that this yield from is very powerful, and it makes things look very pretty when you're doing some very complex operations. So we will move on here, and we'll talk a little bit about building pipelines. So you can see here now that, we had these yield froms, so we can basically go and we can create other generators and have generators call generators, and we can kind of iterate through them. The way that I like to look at this, it's kind of like you can have this generator function, which is going to call other generators, and kind of in my head, it often seems like some kind of like a big geared thing. And when you're actually calling next on it, I kind of imagine it like I can't always picture in my head what's going on exactly inside the generator, but I know that like if I imagine like some little piece of yarn that I'm pulling out of this box, then I'm going to keep getting these values based on how this thing is going to operate. So again, let's go ahead and go through this. We have these verses here. So it's basically just like the bottles of beer song that we had before, except now we have a bunch of different verses that we're going to go through as we sing more of the song. So again, we have this takedown function. And in this one, we are kind of in the same place where we have some number of beers on the wall. And if this is greater than 0, we're going to keep doing something. And then if we have none, so when we instantiate this, we're going to stick in this while loop until we have 0 beers. Once we're done there, we're going to yield this instead. And then let's just get started and go ahead and do this. So you can see here when I do the sing method that we have sung this entire bottles of beer on the wall song. You can see here that we have our verses. You can see here that we have our verses. And we just iterate through as we're going and until we get down to the bottom. And then you can see we have 0 beers on the bottle on the wall. And if we have none, then maybe it's time to go find another bar. And during the talk, I made a little joke about how we go to the bar afterwards. But again, you can see here that we can build pipelines where generators can call other generators, and we can get some complex behavior out of this. Again, if we wanted to do this manually here, we can go ahead and just create this instead of having this inside of a for loop. And you can see that we can just start implicitly getting verses for this every time. And where this is, useful in robotics applications, again, we can get one verse, we can do some other things, and then go ahead and, get the next one. We can do whatever the next thing is after that, and we can, get some kind of choreography going with different functions working at the same time. Which so let's up the difficulty a little bit. And just thinking of generators as iterables themselves misses a lot of the true power that they have. So not only will generators allow you to just extract values out of them, like the yield statement. So every time in the examples above here, we always have some yield, and this next here, we aren't really passing anything into them other than when we instantiate the function at the very beginning. We can do things with them while they are alive, as it were. So again, we have our generator object here, which is going to be of this type simple. So we have a generator object of this simple function here. So let's go ahead and look at how this works. So we have just created this simple generator, and the first thing that we always have to do on a generator is to next into it. So this is going to be the first thing that you're going to always have to do. And what that's basically going to do, we have instantiated this generator, we've called next. So we go bloop, this happens. You can see this is our first yield. And now kind of if you were to think about it like our cursor is on this next yield here. And our function has yielded, and now our generator rather has yielded, and it's kind of just sitting here waiting for something to do next. So, and now we can send something back. Again, we have this generator object still. We can invoke the send method on it. So let's go ahead and just send in hello. You can send in anything you like. And you can see here that we have sent in hello here at this yield again. Value is now equal to whatever we sent in. And we are going to post, which is just going to put it down here. Value equals, again, we're just creating a string here of value. And you can see here that we have value equals hello based on the hello that we sent in right here. So we've gone through, we've yielded, we have send a value in. We have posted this out. And now if you want to think about it again, our cursor is now on this yield statement, and we can yield something back again. So let's go ahead and just hit the button. We're going to send in 10. And you can see a stop iteration has come up. But you can also see that we got our second value. We have posted second value equals, whatever the second value is, and you can see that it actually did print this here. After that, there were no more yields, so it raised this exception of the stop iteration. Let's go ahead and create this again, and we'll go through it a little bit quicker. So again, we have a new generator object of type simple. I click this button right here. We have not done anything. We have just created this. So let's go ahead. First, we're going to next. This is our first yield right here. Let's go ahead and send in a 5. We printed, or posted rather, 5. We now are waiting to send in something else. Let's go ahead and send in chipy. We sent in chipy. We got back here second value chipy. And then again, this has just exhausted the generator, and we have gotten a stop iteration. So let's go ahead and move into this not so simple operation here. And this is where some of the syntax starts to look a little bit unusual, but once you get a handle on it, this is it's not so bad. So we have created this generator object again, this time not so simple. And with this one, again, first thing that you're always going to have to do when you create a brand new generator is next in. So basically, we are going to next in and kind of like bring our cursor right here. And you can see that in this, we actually did yield this 5. So that's one thing to keep in mind. Just like when we have in all of the other ones, we are going to yield some value. And that's always what we did. Again, you can think about it like up here. We came in here and we yielded this string. When we do this here, we come in and we're just yielding this 5. We didn't send anything in, but you can kind of think that our little cursor here is on this yield. So now that our cursor is kind of like on this yield here, we can send something in. So let's go ahead and send in a 10. And you can see that we sent it in, and we actually ended up getting a 10 back because we decided whatever we send in, we're just going to yield it right back. So again, what's going to happen now if we go ahead and try and send it something else? If we try and send it something else, again, we're going to get our stop iteration just like if we did a next. And somebody actually asked the question here. Let's go ahead and start this one again. So what is going to happen now so let's go ahead and next. Our cursor is right here at this yield. What would happen if we decided to not send a value in, if we just decided to next on this example here? So that was a great question. So I'm going to go over it here. And what's going to happen is this actually happens under the hood. I apologize for that. But what ended up happening was, no, it doesn't show up here. It basically passes in none. So it's like doing gen.send with a none in there. So that's something to keep in mind. But again, generators, while not necessarily complex, they do require a bit of hand-holding and to kind of understand what's going on under the hood, especially when you're trying to invoke some of these send methods, making sure that you're sending in the right type of object or any other kind of complex behaviors. So moving on here, you can see here, now we are going to try and get some concurrency going, which is basically going to say we have a bunch of things and we want to do them all at the same time. So, you can imagine here that like we're going through and we have a bunch of different functions that we're kind of doing at the same time, and we want to kind of work on all of them at the same time. So let's go ahead and kind of get this party started, as it were. And you'll see that as soon as we get to some of these later slides, why I kind of have this start party method and all of this to kind of illustrate how this is similar to some of the other Python things that you might be used to. So again, we have just created this gene object here, and we'll go ahead and call next on gene here. And you can see that there are currently no running generators. So that's kind of with this one right here. It's like we have called next, and we have no generators in here. So there's nothing to do. Gene here will kind of just handle a lot of these things silently and just be nice about how she creates things. So again, we have no generators here. You can see we are just like asking for the keys of all of the generators that you may have. So let's go ahead and we will just start a generator. So gene, we're going to create a generator, and we're going to pass in this string just called alpha. So let's go ahead and look at what happens up here. It's like we are going to create a generator. We're getting a name, which we're passing in, called alpha. We are going to default to calling these iterations. We're going to default to iterating 5 times, just so we can kind of get a view of how many times we're stepping through this. And then we're basically just going to like yield a string saying who it is and what they're yielding of the number of generators. And then we will go ahead and pass this generator that we've just created right here into Gene so that she can hang on to it. So you can see here now we have this generator called alpha. Let's go ahead and next on this, and you can see that we have a generator and we are going through all of these, and you can see that also Gene has quietly handled the stop iteration and closes it and removes it from her list of generators. So again, we've exhausted this. Alpha's been removed. We currently have no generators, and things are working pretty cleanly here. So let's go ahead and we'll start it again. We have a generator again that we're going to call alpha. Let's go ahead and next on this. You can see that here we're 0. Let's go ahead and create another generator now. We still have alpha. Alpha has started. We are now going to go ahead and pop in beta here. You can see here that when we do this, we can see that we have 2 generators that we're going on. We can go ahead now and start this, and you can see that as we go through here, that we are alternating between alpha and beta, and we are getting our new values. So let's go ahead and put in delta now. We have 3 generators going. All of them are going to be at different stages of their iteration. Also keep in mind, they are out of order for the same reason as above, where we are running in MicroPython, so dictionaries are not necessarily going to hold their order. We can use the ordered dict object if we wanted to, but I just wanted to keep this generic to show you some things that you might run into if you're just using regular dictionaries and not understanding why we're not getting these things out in the correct order. Again, to continue on, we have a bunch of generators all at different stages of their iteration. So let's go through here. You can see now that alpha has completed. Let's go ahead and look again. We are down to only delta and beta. Let's go ahead and throw a gamma in there. And we'll go through these kind of quickly. We're going. And we have exhausted all of them. And we currently have no more running generators. So again, you can take generators, you can go ahead and throw them into some kind of object that can kind of hold their hands and take care of them, and use something like this to generate some kind of concurrency. And let's go ahead and move this in. And some of you might start to think that some of this looks familiar. because this is the very similar type of context that you have with the asyncio module. And with the asyncio module, you end up with these new kind of keywords. You may have seen await. And await is basically just like a kind of fancy yield from. So we are awaiting for some database to get back to us. And so it's basically like yield from, because under the hood, this particular generator is going to kind of sit there and return nothing until it actually gets something. But in this case, Gene or asyncio is going to be able to kind of handle the fact that this thing has passed back none and it's not quite ready to be closed or to go to its next step as it's doing this. So again, asyncio, just like Gene, kind of does a lot of the hand holding that's required for some of these things when you're trying to do concurrency. One thing to kind of keep in mind as you start, or if you start adding async IO and async functions to your project, that this is a kind of like a design paradigm that you are going to have to that's going to kind of like bleed into other areas of your code. So this isn't a problem. It's just something to keep in mind, that like as you start putting these in there, that it's going to kind of change your code a bit, and your code is going to work a lot nicer if you just kind of start working in the paradigm of what async would like you to do. So again, we have a little code block here. We have imported async IO, and we have created this little function here that is going to post something. It's going to sleep for a little while, post something, sleep, and then post again. So again, we have our loop, which is the event loop of async IO, and we can take this loop and create a new task of this function. So let's go ahead and do that, and you can see that we are posting, waiting a second, posting, waiting a second, and going through. Let's go ahead and look at this function as well. So let's go ahead and type that in there, and you can see that even though this is what you would think would be a function, actually gets returned as a generator. Also keep in mind that this is MicroPython, and CPython may return something different. But just to keep in mind here that, like, what's really happening under the hood when you're using an async IO module or one of these is like, it looks like you're creating a function, but what you're actually doing is creating a generator. So, and the creation of this generator is kind of handled by this async keyword. So let's go ahead and just do a bunch of these here, and you can see that they are all happening at the same time. Let's go ahead and see if we can kind of get these, and you can see that we have a bunch of them that we fired up, and they're all kind of happening on their own time frames. But we are getting some concurrency going to have them all kind of do their thing on their own, and yet still have our single-threaded operation. So to kind of start closing some of this up, we're going to bring this back to robots. And by the time that I'm making this video, I had already posted some of the videos on collaborative programming and on this checkers game here. So if you want some more information on how we actually went through and created our game, you can go ahead and look at those, but I'll just give another little overview here to kind of close this up. So when we're creating this game of checkers here, we have a bunch of different things that are going on at the same time. We have a bunch of global variables about, how is the board set up? We have this notion of a board as locations in space. We have this suction cup that has some, vacuum pumps attached to it, and it needs to move up and down, and we have a robot that needs to move around, and so we have a bunch of different pieces that are all needing to be handled, and how are we going to go through this and create something that's going to Well, let's go ahead and look at this here. And again, quickly, we'll just kind of, we'll go through this fairly quickly, but we kind of just have some constants here. This is like, we're going to pick up the suction cup and we're going to put it down. How fast are we going to move? Is this feed? Where is the bucket that we're going to throw stuff in when you remove a piece from the board? Where is that? We have the board itself. Again, the board is located in space, so we have the angles of the arms, and we're going through and we're going to play this game. If we go down all the way to the bottom, oops, sorry about that. This is the game that we're actually going to be playing. We can kind of start from the bottom and move up here, but we had our board up there, and you can see here that we have A, B, C, and D as some columns, and we have our rows here, 1 through 8. And you can see here that we are doing some moves here. So this particular one, we're moving from D3 to D4, or I'm sorry, rather D3 to C4. And we're basically doing a bunch of moves. You can see here with this one, we would be removing a part. So let's go ahead and just get this started. So we're going to create a generator object of this play game type. You can see here, play game, and we are passing in this game object. This game object is going to be this list of strings here, which is a list of the moves that we want to go through. So again, we've created it. Let's go ahead and start here. So first we're parsing some moves. You can see here that we're moving a piece from D3 to C4. So we are going to yield from, which again is basically just like an implicit for all of the moves in this pick function here. Go ahead and yield all of those. So from pick here, you can see that we're generating some kind of move command. We're going to move the robot. We're going to tell it to turn on the suction cup. We're going to pick up the piece. We're going to move on. Actually, why don't we go through this? So you can see here that we have moved to a place on the board. We are moving our suction cup down. We are saying, hey, go ahead and turn our suction cup on. We're going to wait for a little bit for the suction cup to actually suction our piece. We are going to move back up again. And we are going to move to what in this case is C4. And if we wanted to go ahead and take a look at this, we have this get position function. Oops. We have this get position function. And with this, we can pass in a string. So we have this, where are we going? A6 here. So let's go ahead and just do this. So you can see here that we are returning a XY location here, and you can see, actually, I don't think that this is where we just dropped off. Let's go ahead and next and see where we're at. We're moving back down. We're turning the suction off. We are sleeping for a little bit to actually drop the piece off. We're going ahead and moving back to a clearance position with our Z. And now here we are actually going to move to position A6, which you can see here when we did get A6, you can see that these are the same values that we have in here. So again, this kind of seemingly simple set of generator functions here is going to generate some pretty complex behaviors as we're going through and moving and playing this checkers game. And you can see here that, as we do this, we're just yielding these moves, moving around, picking up places, placing them, moving them off the board. And yeah, so that was kind of everything for this talk. If you wanted to see more about this checkers game, again, I've got another video posted on the channel here on our collaborative programming series, and I advise you go take a look at that. But again, let's go ahead and open this last one. just we have a crowd supply campaign going at the moment, and we'd love to have you subscribe to that. We're also releasing the source files for a lot of our different hardware and software and everything. So kind of the best place to go to keep up to date on that is to subscribe on our crowd supply campaign. And thank you very much. Can't wait to see what you guys do with this. And we'll see you next time. Thank you.